It makes you realize why this type of visualization has such a surprisingly emotional impact on people. Because when you watch this, you aren't just verifying that Pythagoras was right. I mean, you don't need a computer to prove the math to you.
No, not at all.
What you are actually experiencing is the visual representation of absolute stability inside of absolute change.
And human cognition is deeply wired to seek out patterns and stability. We live in a world that is inherently unpredictable, where systems are constantly shifting.
Yeah, to say the least.
So when you watch a mathematical truth adapt dynamically to violent, rapid changes without ever breaking its internal logic, it actually provides a profound sense of cognitive relief.
It proves that the foundation is solid, no matter how much the house shakes.
Right.
You have these vibrant green squares, inflating and deflating, desperately adjusting to the chaotic input of the user dragging the mouse.
Right.
And then you have this massive anchoring orange square on the hypotenuse, responding in kind, maintaining its dominance, but always yielding perfectly to equal the sum of the green.
You are watching a system that is constantly under stress, constantly forced to adapt, and yet it never compromises its core integrity. The continuous truth remains completely untouched.
And think about what that means for modern engineering or physics or like data visualization. We rely on continuous truth for literally everything.
Oh, absolutely.
When a structural engineer is simulating how a skyscraper will react to an earthquake, they aren't just looking at the building before the quake and after the quake. They need to know that the mathematical models governing the physics of steel and concrete are going to hold up at every single frame of that vibration.
It is the bedrock of parametric design. In modern architecture, designers don't draw a static building anymore. They define a set of mathematical parameters and relationships, just like the relationship between the green and orange squares, and then they alter the inputs.
Wow.
They change the wind load, they adjust the footprint, and the entire structure morphs and adapts in real time while maintaining its structural validity. This simulation of the Pythagorean theorem is literally the purest, most elemental version of that exact same concept.
Which brings us full circle to where we started. We